now that I'm amplified and you can hear me properly. Welcome, welcome. So, this afternoon we're going to talk about the next wave of mobile apps, or more specifically, hybrid apps. My name is Ryan J. Salva. I've got with me my good friend Jordan Mathieson. Say hi, Jordan.
Hi, Jordan. I mean, hi, everybody. Can you hear me okay?
Yeah, so we're going to get going here. So before we start all of the edumacation, this is intended to be a conversation. I know I'm up here on a stage and you're out here in these lovely stadium seating kind of desks, but let's make it a conversation rather than a presentation. Interrupt me, interrupt Jordan. Let's talk questions and make it interactive so that we can all learn. I'm more than happy to divert as necessary. Sound like a plan? Yes. Interrupt me. Yes. All right. Good, good. So I'm gonna start in a little bit of an unusual place today. Anyone who even casually knows me knows that I am a gigantic David Bowie fan. I love David Bowie, which made it pretty sad when he died this last year. And I kind of took that as a moment of reflection to kind of think about David Bowie as not just a person and an artist, but also as a cultural icon that somehow managed to stay relevant for what, over 50 years of a career, right? A hugely long time. And I was thinking to myself, how is it that anything manages to stay relevant through the 60s, the 70s, the 80s, the 90s, the thousands, or the aughts, if you will? That's a long time to remain culturally relevant. And a lot of it, I think, derives from the fact that David Bowie was able to reinvent himself every few years. And that act of reinvention kept him relevant to us as a cultural icon, as an artist, as a fashion icon, whatever. And you may or may not like David Bowie, but you at least have to kind of acknowledge that he remained relevant. And that, through that reinvention, he remained kind of present in our minds. And that's not true just for people, but it's also true for the technologies that we use. And there's really no technology that, at least I know of, that has been able to remain relevant through the act of reinvention so much as the web. HTML, CSS, JavaScript, and everything that we know of as being web technologies. Whether it was kind of at the birth of the web back in 1991 with DARPANET and us kind of exchanging so many essentially plain text documents with H1 tags and span tags, and actually did span tags even exist back then? I think it was just paragraph tags, and maybe there was an odd blink tag here or there, right? Or as we approached the aughts in 2000, maybe 98, 99, when those documents turned into actual interactive websites where we weren't just exchanging words, but we were exchanging dollars and starting to really create applications out of the web. And then as you fast forward a little bit more, the web reinvented itself again. Well, in 2007, Apple, in all of its glory, brought us the iPhone. It was a cool thing, right? Let's see, one of these guys here, right? One of these things here that all of a sudden we could take with us, and it was location aware. It knew that I was at home versus work. It was spatially aware through the accelerometer. It was connected into other services like the address book, right? And so in 2009, when PhoneGap was invented, literally to bridge the gap between what a phone was capable of doing and what the web was capable of doing, the web reinvented itself again to bring HTML, CSS, and JavaScript to our applications. So we were now able, as JavaScript developers, to do all the things that a native application could do. We could work offline. We could use native device capabilities, like that GPS device in this little guy, or like that accelerometer, or connecting into the camera or the address book. And so that was pretty cool. The web managed to, spry little guy, reinvent itself again, remain relevant. And now, here we are, 2016, right? Still 2016, I think so? Yeah. And we're at a moment where the web really has to reinvent itself again in order to remain relevant. We're at a place where users, mobile users, expect their applications to behave a certain way, to look a certain way, to perform a certain way. And that way has a lot to do with the brand of phone that they're holding in their hand. They expect material design theme for Android. They expect, I don't know, Johnny Ive design theme for Apple. Does it have a name? Does Apple have a design language name? They expect Windows design language for Windows. And so unless these applications are able to adapt to the look and feel and represent the same performance characteristics that they get out of native languages, well, the web's got some work to do. So that's important. I believe that's important. As a JavaScript developer, I believe that's important because there is so much knowledge that is trapped up there in that red line up there. This is a survey from Stack Overflow of this year, I think March. So these are pretty fresh numbers. JavaScript is used by about, I think it's like 55, 54% of developers as their primary language today. That is a huge number of developers who are fundamentally web first. And for them to continue to work in a mobile app economy and really remain relevant from a career perspective, we need to find ways to keep the web relevant. And today, developers are being pretty successful at it. Now, this particular stat, this comes from a Vision Mobile analysis almost exactly 1 year ago. So the data's, a little bit old, but not too old. Frankly, I suspect if we were to cast this survey out again, the line just underneath, PhoneGap Cordova with Xamarin, would probably show a nice bump, especially since the acquisition of Xamarin by Microsoft within this year, right? So if you look at this, the red indicates developers who are using this tool actively today, and the green is developers who prioritize this above all else. PhoneGap Cordova takes the cake. Way more developers, in part because it's been around for so long. In the timeline we saw earlier there, you saw Cordova being kind of brought to market in 2009. We're now at 7 years that it's been around. And in that 7 years, Cordova has had an extraordinary opportunity to mature, to become reliable, stable, to work out all the bugs and the kinks. So there's another layer to this cake, which is, okay, if Cordova makes it possible for us to actually interact with device capabilities, GPS, accelerometer, camera, in order to take it to that next level, in order to adapt to the design language of iOS and Android and Windows, you need another layer on top of that. And the web is tremendously adept at bringing UI frameworks. And heck, there's probably a new UI framework since I started this talk. But one of the great ones, one of the truly great ones is Ionic, especially for mobile application development. Ionic is terrific because it adapts to the design language of the target device, and it provides a lot of kind of the syntax sweetener that you need in order to be productive. So I want to talk today about Ionic. And you guys probably already heard Brian Noyes talking about Ionic earlier in the week. Was it this morning or yesterday? I think it was maybe yesterday that Brian was talking about Ionic. Now, when you saw Brian talk, I believe you would have seen him talk about Ionic 1. Today, we're going to show you Ionic 2, which is in beta, but is expected to release as a official release to market, worldwide supported candidate a little bit later this year. So why Ionic? Well, first and foremost, because it is obsessed with performance. When you put your finger on that device and you drag the menu down, or you scroll quickly through that long infinite scroll, infinite list view, you need the device to keep up with your interactions, right? And HTML, CSS, and JavaScript are capable of achieving 60 frames per second, but it takes work as a developer to do it. And so the Ionic team, in conjunction with the Microsoft team, has really worked to make sure that all of the controls that you get, those native-like controls, are performant and are achieving that 60 frames per second that we all expect. It's also built on top of Cordova, which means that you automatically benefit from all of the years of effort invested by kind of the behemoths of the software industry. Companies like Microsoft, or Google, or Adobe, or Intel, or IBM. All of these are major contributors to the Cordova framework and contributing to make sure that Cordova is reliable and up to date and really like the de facto choice for any business wanting to create especially line of business applications. And because of our partnership with Ionic, you also get a better developer experience from within Visual Studio. We worked really hard with them to make sure that when you are inside of VS Code or Visual Studio, you get the best possible experience, in large part because Ionic 2 and Angular 2 brought TypeScript as the preferred first-class citizen. So rather than use JavaScript first, these frameworks have chosen to use TypeScript first, in part because it affords the ability to use features of JavaScript future today, so that you're able to use things like decorators in a world where not every JavaScript engine understands how to use decorators, so that you're able to get a better development experience by virtue of kind of the refactoring features that you can get out of a strongly typed language. And we'll see a little bit of that later on. So with that in mind, you've kind of got a good idea of where we're going with this. Let's actually take a look at an app that we're going to walk through the code on so that you get an idea of what it is that you can build with Cordova, Ionic, Angular, and TypeScript. Jordan here, you want to bring it up? All right.
All right.
So what do you got here, Jordan?
So what I have first to show everyone here is I'm using an iOS device, and we're going to show you the conference application that the Ionic team has built, which we've adapted with Azure App Services as a back-end data store. And this is, if you've been at any conference, which I assume you have been because you're at one right now, you may be familiar with the session browsing experience and trying to pick your favorite sessions that you're going to go to. And that's what the point of this app is I have the ability to go through and see the sessions that are at the event I'm currently attending. And you can see some things here as I'm scrolling that, first, I think the performance is fairly nice, even with the maybe a little bit of a lag onto your screen there. You can see that the scrolling is fairly smooth, and I get some of the iOS design language, the Johnny Ives language, of my times sticking here as I scroll. So if I go up, you'll see that 1 o'clock p.m. is stuck up at the top of the screen as I scroll along. I have some other iOS affordances, such as sliding an item here. I could add it to the favorites. And I get a dialog that looks like an iOS native dialog. I can switch over to the favorites here, and so I've got a tab experience similar to other iOS applications. Things like filters and toggle switches that let me filter my sessions in this case. So say we're not interested in services, I could save that. I also have a drawer component through our friend the old hamburger menu there. And I can come and navigate through here and go, say, take a look at a map and get a map experience. And so that gives you an idea of what the iOS look and feel would be like. Now let me switch over here and show you on an Android device. We'll switch our inputs.
Not up yet.
I will toggle this screen.
One of the joys of cross-platform development is that you get to carry lots of devices in your backpack and get to switch between lots of computers. It's a little bit easier when you're presenting here in Redmond, but when you're traveling across the country or across the world, going through security they're like looking at you like you're a thief walking through with like, you got 2 Android devices, a couple of iPhones, maybe a watch.
In this case, it's not even the device, it's just the
It's
display
just the,
technology on my
AV.
laptop.
Okay. Well, I'll tell you what, we've got a specialist coming down here to resolve the issue for us.
Just the adapter on this machine. Okay.
There we go.
The Android version of this application, same source code is running, which is one of the benefits here of using the web technology and Ionic, is I've got the same source that you saw from my Android app.
Oh.
is the same as what you just saw on the iOS application. Okay. And so this here now, you're seeing the same kind of app, only the UI is adapted more to material design. So my bright, bold colors, my tabs, if I switch here, you'll notice a ripple effect. A subtle effect on the side of the tab that I'm tapping on gets a ripple effect. That's part of the material design language. Similarly, if I look, the drawer is a little different. Yep. And you can see toggles on the device fit more of the Android look and feel.
Yeah, things like the title where it says filter sessions are left aligned rather than center aligned. Typography is different.
Add an item to favorites, and the dialog is more square than rounded.
All right. Cool.
So there's our app.
That gives us an idea of what we're going to be building. All right. All fairly straightforward. We get that? Yeah? Okay. All right. So let's talk a little bit about how this is all put together. We're going to get some AV. Yeah. All right. Oops. So let's talk about kind of the architecture of how all of this magic happens, right? So we're going to start by creating the app. And the app is fundamentally written using web technologies. Reinvented, trademark. And so here, you've got all your HTML, CSS, JavaScript files, and images, any assets they're going to use. And those are going to be packaged up with the app. So everything that you see that's in kind of bright green there, those are personal developer assets that you have created. Everything that you see in orange are going to be libraries or artifacts that are brought to you by the toolchain. So also packaged up with your own HTML, CSS, JavaScript, and images are your frameworks like Ionic and Angular, your platform code, which is provided by Cordova, and your plugin code, which is giving you access to the native device capabilities like camera, barcode scanner, anything that you're going to use there. So from there, what's going to happen is Cordova is going to do a build. And when it does that build, it's going to essentially stamp out 3 different projects using the SDKs of each respective platform. So either Visual Studio and the Windows SDK for Windows, Xcode for iOS, or the Android SDK for Android. And it's going to copy those HTML, CSS, and JavaScript assets to each one of the projects, along with the platform-specific runtimes for each of those. Then it will output the actual APK or the Windows one or the iOS one, right? And so those will ultimately get installed on each of your devices. From an architectural perspective, it ends up looking a little bit like this. You've got all of your native plugins, right, which are down here on the bottom. And I've listed, what, maybe 8 or 9 or 10. There's actually a kind of a community and an ecosystem of over 1,400 plugins out there. So if there is some kind of native capability that you want, there's a damn good chance that someone's already built it out there for you. A lot of these are actually built, maintained, and contributed by Microsoft as well. Microsoft maintains a suite of about 40 plugins, which we affectionately call Care Bear plugins because they're the plugins we care about. And doesn't get a laugh, really? No? All right. Thank you for the pity laugh. I appreciate that. All right. So we got all of our plugins there. Then, just above that, Cordova doing its job to kind of essentially bridge the gap between your web view and your native code. Above that, your embedded web browser. In the case of Windows, that would be the Edge runtime. In the case of Android, Chrome. And in the case of iOS, it would, of course, be the Safari WebKit one. And then above that, you've got your frameworks, in this case, Angular and Ionic. So that's kind of a nice little architectural diagram of how everything's put together. Once you know that, let's actually, might as well go here. So all of that together, what does that give us, right? So it gives us close to 0 code redundancy. In a typical situation, when you were building a mobile app, you would write the code once for iOS using Objective-C or Swift. And then you'd probably write something that looked a lot the same but a little bit different for Android using Java. And then you would write it again for Windows using maybe JavaScript, maybe C#, maybe something else, right? And all of that results in what is an awful lot of code redundancy. Now, Cordova and Xamarin both bring the same benefit that you're able to eliminate that code redundancy by using a single language to distribute to all 3 platforms. you also get access to all of the native APIs by virtue of the plugins. At the time I put this together, there were actually 1,125. I mentioned the 1,400 number of plugins because I went back and did a double check this morning, and it's now just north of 1,400. And you get offline support because all of those HTML, CSS, and JavaScript assets are packaged with your application. You got offline support. You're taking it with you. You don't need a server connection all the time. All right, so now that we got an idea of architecture and kind of how that all wraps together, let's actually jump into some of the code, right? Let's kind of do what we came here for. All right, so Jordan, let's take us through this. Take it through.
Down to Demo Town, okay.
Time to demo.
So what I'm going to start with here is we're going to look at the source code for this app now, and we're going to first work in Visual Studio Code. So who here is already familiar with Visual Studio Code?
Me.
Okay, so if you aren't familiar, real quick, it is a lightweight editor that gives you a lot of the tooling you come to know and love in Visual Studio editors, and it makes it available to you in a smaller package you can install on Windows, Mac OS X, and Linux. You'll see I'm using Mac OS X here. Our team has built a Cordova extension on top there that you can add into VS Code, and so that's what we're using here when we do some of the functionality we're going to play with. It integrates with Ionic and gives you some extra support for IntelliSense, some simulation of the tools, so we'll show some of that. We're also going to work with the TypeScript language. So who is familiar with TypeScript so far? Okay,
Yeah,
so I'll talk a little bit toward what that is as we get in here. The other bits of tech that we're going to hit upon, which Ryan mentioned in your architecture overview, is, well, Ionic, of course, Ionic 2, which is built on top of Angular 2. And so is anybody in here familiar with, let's say first, Angular 1?
Yeah, most everyone.
Good mix.
All right.
And how about Angular 2?
Yeah.
Okay, so I won't even say there's some similar concepts. It's roughly similar, but they're very different ways of building applications. So what we're looking at here with Angular 2 will point out some differences, and I'll hit on those a little bit, but if the code doesn't look too familiar to you as an Angular developer, just remember Angular 2 is just changing it up, and that's part of what you're seeing. So first, let's look at the structure of our application here. I'm going to call out our app. The way at a high level this is working is that we have our application files here. These would be the pages of the application, such as the About screen, the Login screen. All of that code that I'm working in for the app is in this app folder. And when I do a build of my project, there is a build task running that's going to take that code and it's going to compile it down into, for TypeScript, it gets turned into JavaScript code. For these SCSS files that are the SAS programming language, they get compiled into CSS. Those all get compiled down and placed into this www build folder. So if you're most often seeing HTML, JavaScript, CSS, those are still here. They are the output of these build tools that are going into this build folder. And in Cordova, it's that www folder that has the core of your app. It is your application running and deployed to the device in that folder. So that's how these pieces move from this one app folder down to www. And let me take one of the pages here. We're going to go into Login. And this code you see here is in TypeScript. But a lot of what you're seeing is actually, with the exception of some pieces like this here that define a data type on a parameter. This is actually very much the future of JavaScript, the ECMAScript 2015 and beyond. So JavaScript is getting the concept of classes, getting the concept of modules, which are kind of like namespaces to us with a .NET background. These are things that are either in the JavaScript language and coming into browsers now, or there are future proposals for things to come into JavaScript, such as this @ syntax called the decorator. These are future features you can use today, which Ionic 2 and Angular 2 development have you using now through TypeScript. So TypeScript is enabling you to use the future of JavaScript today by letting you work in this higher level language that really in the end is just JavaScript that gets built. So I'm giving a very simple intro of what TypeScript is there, but if you look at the website is typescriptlang.org, that's where you can learn all sorts of info about it. Angular 2's own website, angular.io, has a tutorial. Ionic's got their own tutorials on their website. Some major differences to those of you who are used to Angular 1, you'd be very familiar with the dependency injection model there, where you'd have a function that had, through the magic of parameters, it would call out dependencies to other modules that you could then, say, take a dependency on a log provider and then use logging code in your controller. Well, instead of having that JavaScript magic strings for dependency injection, now you've got support through TypeScript of having these modules. So I can define my dependencies between different components, different modules using this import syntax. And I can see, for example, this user data here. I could take a peek and look at the implementation of the user data class and be able to dive down deeper into there. I can also get some level of dependencies through types being specified on my parameter. So here I've jumped in and I can see that this constructor takes an events argument and it's of type events. So TypeScript is giving me events, giving me types, a type system I can work with. And that gives me some higher accuracy IntelliSense and different tools that we can use. So back on our login screen here, I'll call out a key thing to know about in building out the Ionic app is this component decorator. So decorator, it's a little similar to attributes in .NET. You can think of it as adding extra metadata to a class, or I think you've used a nice analogy of decorators of if you think you have a tree, you have a fir tree, and then you decorate it, suddenly you could call it a Christmas tree. It's got a bunch of decorations on it. The decorator is just saying that this class has some other info about it. And so with Ionic, they've defined a component decorator you can use to say that this class represents a component of my app. And it happens to say that this component has a template, and it points at this HTML file. If you look at the HTML, this is the markup defining my page UI. And one thing that might jump out right away, with the exception of this file does have some divs. You don't have divs all over the place with a bunch of custom class names and IDs you need to use for styling. You're seeing elements like an Ion header or Ion navbar. These are some of the UI components provided by Ionic to, again, kind of fill in that gap from what you have in the phone world of having a native navbar component. Ionic can give me an Ion navbar that I can plug in, and now I've got a navigation bar that may natively be available to devs building with Swift on iOS, but we don't have that in the web world. So it can give me this nicer kind of markup to work with. So if we jump back again to our class here, one other point I will make around the tooling was when I showed you, I mentioned our higher confidence features like IntelliSense or being able to work with refactoring, for example. I could come and, I could do a go to definition on the tabs page, and let's say I want to change this in my application to call it tabs. I can now go and, actually here's an even better way to do it. I'll show you a couple features at once. Let's go back and first let's find all references to this because I want to see, well, what's the level of impact of this code change I'm going to make? And so I can see everywhere in this code here that, okay, this app.ts file must be defining all of my tabs. So first I could use something like find references, which is hard to do in pure JavaScript because JavaScript being a dynamic language, it all comes together at runtime. You don't have a way for tooling to be higher confident at code time to understand what is a type system, what does this system look like. So with TypeScript, I can find where this class is used throughout my code. And now when I do something like a right-click, rename symbol, and decide to call this tabs, if I hit enter, come on, make the change. Let's try that again. Rename the symbol, we'll call it tabs. Then throughout my code, you'll see that it has been able to find those symbols and change them up. So now I've done a refactoring of some dynamically loaded component in a JavaScript application that was able to, I can make it with more confidence than maybe I could in a previous like Angular 1 application just using JavaScript where I did it really catch every place using those tabs? Okay.
So Jordan, let's take it through and let's actually deploy this guy.
Excellent.
So it'd be fun to actually do this guy. Normally when I'm doing web development, I'm spending most of my time in the browser, right? You guys spend most of your time in the browser, right? So when I'm working with a mobile app, I'd actually like to do a lot of my basic construction inside of a browser as well. And so within VS Code, we've actually got a handy little feature that we just added, not too long ago, maybe a couple months ago, called Cordova Simulate. Who here is familiar with Ripple? Anyone know what Ripple is? Yeah, we got a few hands in the audience. All right. So Ripple it's been a great tool for the last, I don't know, 4 or 5 years. But frankly, it's gotten a little bit long in the tooth, and it's not maintained quite at the same level as it has been. And so we kind of set about the task of re-implementing, not re-implementing, but creating a new kind of evolution of Ripple. And we call that Cordova Simulate. So for this one, you guys will see that we got in our drop-down menu here for our debugger, we've got a Simulate iOS in browser and Simulate Android in browser. That's exactly what it's going to do. It's going to invoke Cordova Simulate, which you can think of as a new version of Ripple. Jordan's going to go ahead and do that, and what you're going to see here is it's going to launch it to Chrome. And while it may take a second here to load up, yeah, there we go, we got it. So now we've essentially got out, because we're just running HTML, CSS, and JavaScript, there's no reason it can't run in the browser instead of on a mobile device. We're just going to run it here in Chrome itself. And from here, we can do any of the normal things that we would do with our debugger. And even if we've got plugins that we're making use of, let's say that we're making use of, I don't know, we're making use of the map for geolocation, certainly on the maps page. We might be making use of, let's see here, we got a couple of viewport devices, all sorts of different things here that we can emulate just inside of the browser without having to redeploy it to a device every time. Now that's pretty handy, pretty cool, but one of the reasons that we tend to use the browser, or at least that I tend to use the browser, is that I get a really tight inner dev loop. I can tweak a couple of things and automatically kind of hit refresh and see it update really quickly in the browser without having to do a completely new build every time I just want to tweak some CSS or some HTML. And so you get the exact same thing here, right? So if you go over to, let's see here, go to the tabs HTML, let's change one of those to, say, instead of about, say, Space Cat.
Gotta have an
Space
exclamation
Cat.
point.
All right. So now our About tab should update down here. Space Cat. Oh, wait. There it is.
Space Cat.
Space Cat. Right? So without having to do a completely new compile, we were able to just kind of zing, put all that new HTML, CSS, and JavaScript in there. And that gives us a much tighter iterative development loop so that we can be playful with our development and kind of experiment and move things around pixel by pixel without having to go through a 30-second, 1-minute, 3-minute compile step every time that we want to see just a couple of our changes realized. Now, that works for Android, that works for iOS as well, but sometimes we actually do want to deploy to a device. Sometimes we actually want to see kind of the real thing. So for that, let's actually do that. Let's kill our simulator here, and we're going to, let's actually take that to iOS. Awesome. So we're going to use that same tethered iOS device that Jordan had there, and we're going to deploy to it. Here we are. Is it doing our build still?
Still doing the build.
Still doing our build. See, this is why we like the browser, because we don't have to do that build every time. We're going to let it do its build, and eventually that guy's going to deploy.
Wrong button.
It's thinking about it while we do some of our window management.
I just like to lay my screen out a little differently. There we go.
There we go. All right. So eventually this guy's going to build, and from there, oh, here we are. Hey, build.
Okay.
We're attached. Dun, dun, dun. All right, so we're going to go over here. We're going to go to our code. And now, from within our editor, we can set breakpoints, do all the normal kinds of debugging that you would normally expect out of a full IDE experience. But this time, inside of a relatively lightweight, essentially text editor, which is really what VS Code is. So you want to put a breakpoint on that guy? Awesome. All right, so we put it on our navigation for go to session. We're going to navigate around here, so let's do it. Let's navigate. Hit the breakpoint, and now you can mouse over any one of those objects, kind of see what's inside of it. We can establish watches. All the same good kind of debugging that you expect out of an IDE once again. So this works. One of the lovely things about this is because it's just using the Chrome Remote Debugging Protocol, it can attach to anything. If we want to attach to a browser and debug, cool, man, you got it. You want to attach to an emulator? Yeah, why not? To a tethered device, you got it. To a device that's not even tethered, you could do that too, so long as it's on the same network. And so Visual Studio Code essentially here becomes your kind of Swiss Army knife of web development, and mobile development. And that's pretty cool stuff. All right, so as cool as debugging inside of VS Code is, sometimes you want to do something a little bit more. Sometimes you need to work with services. Sometimes you want a full-featured IDE. So let's do that. You want to do that? We're going to take it on over back to our Windows machine. Hopefully the AV cable is going to work for us this time.
It looks very happy this time,
Yeah,
yes.
it looks very happy. All right, excellent.
So
And Jordan, why don't you take us through kind of using some of this code inside of Visual Studio and explore some of the services that are possible through there with Azure.
Yeah, excellent. So now we're back. We're in Visual Studio, and this is another set of tooling my team works on, the tools for Apache Cordova, or we'll affectionately call them Taco. And so these are the Visual Studio Taco tools that allow us to load a Cordova project into Visual Studio and get debugging capabilities for Android, iOS, and Windows devices and emulators and in a browser. This time around, we're going to focus on code in here, and we're going to look at some of the services. I want to focus first on, let's talk about how we do some of the logic of this app. So I'm going to go back here to my Android app and show you one of the features of this, which is a login screen. So for me to be able to handle and save my favorites, I'm going to log in with the service. And this app happens to support Facebook, Twitter, and Google. I could also add in a Microsoft account or Azure Active Directory if I wanted. I'm going to sign in with Twitter, and I may actually already be signed in on this one.
Communicating with the Twitter API.
You can do it.
Go a little spinner.
While that's running, you can see that the... OK, so it actually just put up a screen. OK, that's good. It just put up a screen. I was already logged in, so it was redirecting back to the app. So now when I add favorites here, they're going to be tailored to my account. And what we're doing here, first, we'll focus on that login piece and how we did it. The data being stored is also being stored up in Azure, and we'll look at that in just a moment. For login, we're using up in Azure, you've got, reset my screen. Got a fairly simple setup for adding in support of these different providers. So if I come back in here, go back to our app dashboard, and I'm going to open up the authentication section.
So the piece that Jordan's taking you through here is all part of Azure Mobile App Services. And these are essentially a collection of services, including authentication, data synchronization, offline data storage, which are all designed to help mobile developers become more successful. There are services available for, well, just about any platform, but two of the kind of standout ones are both Cordova and Xamarin within the Microsoft ecosystem. So we've got the authentication one here.
So here it was I was able to search for auth, and you would find this authentication section. And in here we've enabled app service authentication and already done the work to configure Google, Twitter, and Facebook for auth. And once you've done that, I don't know how many of you have actually done some login code for an app before or had to maybe integrate with OAuth. Yeah. OK, so you've been through the pains a little bit and might know what I'm talking about. When I've implemented this before for an app where I was trying to log into Instagram, I know it took me a while just to figure out how to get started and get all these callbacks and everything set up just right.
Pardon my French, but it's a pain in the derriere.
Exactly. So this is where I like the support of there's an Azure App Services plugin that provides you a JavaScript API that you can use to handle that kind of communication for the login, and it takes care of a lot of the plumbing for you. And if we look here in our user data code, you'll see that we have our a little error message that we will pretend did not happen. And we have our login codes. This is really the core of what we will do here to do the login. So I knew up a mobile service client class pointing at my service up in Azure, and then I'm calling a login function. And this login function, in this case, it's taking a string for provider. We provide those strings just from the buttons on the UI of the app. So when I click Twitter, it'll pass a string for Twitter back to this API, which just maps to what the Azure API expects. So all that's doing is saying log in with Twitter. And it's going to use JavaScript promises to say that when that is done, call this callback. And so it's going to call this login response function when it is done with the login process. And then I just get a response object back for which I can do some things such as setting the username in the UI, storing a user ID for later, and publishing an event that will tell the rest of the system that login has occurred, and then the UI can respond in different ways to the login.
Yeah, this freaking blows my mind every time I have to write this. Like that you're able to do all of the OAuth with effectively 2 lines of JavaScript and then whatever your event handler happens to be. Like that is crazy simple. Yeah, what's up? What about authorization? Like what kind of like authorizing the app to do a particular thing? Gotcha.
Like defining
So that would
individual
be
roles and permissions.
Yeah. So this will not this will essentially give you an identity, and then you are free to do with that identity whatever you want to. So if you want to do things like say, this tab is accessible to everyone, but this tab is only accessible to a subset of users, you would need to handle that that logic in your application. So there's no built-in security model associated with it, but it does give you an identity that you can trust. That makes sense. Yeah? Awesome. God, thank you for making a conversation.
So now let's look at the other part of the data store, which was syncing those favorites. So if I come here, I'll go to my sync favorites function that now on login is going to take and do that work of making sure the favorites we have stored up in Azure are the same as what's down on the client application. And this function was written before, I believe at this point, the Azure App Services have offline synchronization coming to their API. They've had it for the .NET C# scenario for a while. For the JavaScript developer, they have some builds now that are nearing final build with offline sync support. We haven't adapted our app to support that, but you can imagine this code here would be simplified from all these checks that just are looking at data locally and in the cloud and making sure they're in sync. They can start to handle that for us. And the exact details here aren't too important of how this works, but if I walk through it here, you'll see that first we've got our favorites are coming from a SQL-like request here to get a table. So we're going to get a table called favorites, and then we have a where clause that says give me the favorites where the user ID matches this user ID, which I just set upon login.
So what for me is really, really cool about this is that you're essentially able to use a SQL-like syntax, I mean, at least the JavaScript version of a SQL-like syntax, in order to access a table or to query a table that is effectively a remote table. That table is out there living in the Azure cloud, and in this case, we're just using, get essentially remote faves table where, and then we provide some queries there, some parameters, and you can make this this particular method pretty complex. You can add and clauses, and you can kind of do joins and that kind of thing. It's amazing that you're able to use a JavaScript syntax here to access this remote table, just like it was something that was local to your app, right? So it's not local data that we're accessing here. It's totally pulling it back from the Azure cloud. And as Jordan was saying here, with the introduction of online-offline data sync, what the same API essentially does is it will first look for an online connection. If one does not exist, then it will look to the local data store and manage that and pull from that data. And then when it reconnects, we'll synchronize back with the two. So it manages all of that for you, which is extremely helpful when it comes to mobile devices, which may not always be connected or have a strong connection to the internet. Tremendously helpful.
To show you the setup of that table, if we go back to our Azure portal here, I'm just going to bring up the table section. And you'll see this feature called Easy Tables. And in here there was a favorites entry that was added. And when you look in there, you'll see our column definitions. They were all just quickly set up in the browser in this case. So just an add button to throw in a table name and then add some quick columns. And now I have my database backend ready to go that API can reach through. So there's favorites. And if I open it up, you can see the data that we've been sending across and saving over here. So it's got some session info and our user IDs that these are all mapped to. And so it's as simple as kind of that setup. There wasn't much more to it in this case. And then from there, if you walk through the rest of this code real quick, we mentioned that the offline-online data story is changing up. But the rest of this logic is, again, using promises that said, sends a request to the server of this read action. And when that comes back, it's using a promise here to say then and pass it this data parameter, which I can now cycle over each item in the data and do some checks to see do I have the favorite or not, and synchronize the two data sets. All right.
All right.
So that is it for the data story with this application.
Awesome.
Now,
should we talk about deployment?
yeah, so let's shift over
Let's
to
do it.
that.
All right. So you got an idea now of what it means to create a Cordova app. You got an idea of what it means to create a good-looking UI on top of that and connect it back to a mobile service. But as we kind of set about the adventure of reinventing the web, you also don't want to throw the baby out with the bathwater, right? You want to keep the best of the web in there. And one of the truly remarkable things about the web is that we're in complete control of our own destiny when it comes to publishing cycles. If you want to push a hot fix to your web server, hey man, do it. Takes 30 seconds and that bug is fixed, right? Or that new feature has been deployed. And with mobile applications, it's more often the case that when you want to fix that bug, well, you send it off to the store and wait around for a while. Maybe 3 days, maybe 5 days, maybe 10 days before the store gods decide that your application is safe and it's okay to publish, and then finally it gets out there. Well, JavaScript enjoys a very, very unique benefit among the store. Because it is uncompiled code, you have the ability to update without resubmitting to the store, right? Any compiled code of any kind, by the terms and conditions of the Apple policy, the Google policy, and the Windows policy, are all required to be submitted to the store. JavaScript, on the other hand, not compiled code. And so we have the ability to publish bug fixes, incremental updates, so long as it doesn't require us to recompile any code. For example, when adding a plugin, you would have to recompile code. But if we're just dealing with HTML, CSS, and JavaScript, we can make updates on the fly. So for this, we're going to use a service that is called Code Push. In fact, you want to, in your web browser, will you go to codepush.tools? Just so you guys got a little visual of it here. Code Push, right. So we really love outer space on the team. Space cats, lasers, anything like that. So Code Push is a service that works for Cordova or React Native applications. It essentially allows you to take your HTML, CSS, and JavaScript assets, bundle them up into a zip, publish them to the Azure cloud, and then from the Azure cloud, your mobile device, all those mobile devices that are out there in the world, on any event you decide, maybe it's every time that a user opens the app for the first time, or every time they open up the app, or maybe it's when they click a button, they will ping the cloud and say, hey buddy, you got an update for me? Azure will say, yes, I do. I've got an update for you. Here's a zip. It will download the zip. It will extract it, replace all of the contents of that www folder that we saw earlier with your new HTML, CSS, and JavaScript. And bada bing, bada boom, you've got an updated app without ever having to go to the store. And that can happen in a couple minutes. In fact, we're going to do it in the next couple minutes. So let's do this. We've actually got Code Push already integrated into the Ionic app. In fact, would you go to Visual Studio and show us real quick the Code Push plugin in the config designer? So those of you that aren't familiar with it, one of the benefits of working inside of Visual Studio is that you've got some design tools that are around it. These are not tools that are available inside of VS Code. But in this particular case, we've added a Cordova plugin called Code Push. We've also signed up for the Code Push service, which, by the way, is totally free, no charges on it. It's just a free service we provide because we love you developers. And then we've also made use of it in the code. You want to go to the spot in the code where we've got the Code Push call?
Will be our About page. So here's one spot where we make a reference to code push.
Yep, I'm looking for the code push.sync method. You can just do a search on .sync.
Oh yeah, in that case it's is over here. Fortunately, the name .sync
.sync is used
sync is
everywhere.
one of those terms in programming that
Yeah, I know, right?
shows up as
You can try code push.sync.
everywhere, like the variable x. I think I know the file I want to go to, but let me finish the search. Okay. Well, we're going to do this.
Let's use some of those awesome TypeScript code navigation tools.
And I believe, oh. And here is where we have our sync call.
There we go. All right. So here's the code that we're using to do it. So in this particular case, whenever we go to push a check for update button in our application, it's going to call this, and it's going to just kind of look to see what application we're using, and we're going to check for an update. And if an update has happened, if you scroll a little bit further down, it will actually do a code push.sync, probably just below it here somewhere. Error downloading package, installing package, go up a little bit.
This uses this install package.
Yeah.
Call.
So in here somewhere, there's a code push.sync thing. Bottom line is that's what's doing the call to go out and ask the code push server if there is an update available. So all of this, we're going to execute, we're going to kind of initiate by pushing an update to our CI/CD service, or continuous integration delivery service, which in this case happens to be Visual Studio Team Services. You don't need to use Visual Studio Team Services. That's just how we've got it kind of configured to do. So do we have any? We made the change to SpaceCat, right? So that should show up if we.
Not in this.
Not
on
on
a different
one?
device.
You want to make a quick change
But in this
there?
case, what we've got is I'm missing a link there. Yeah, we can make the change to SpaceCat. Let's say that it's the night before the conference and we want to relabel that About button because Ryan is that kind of a manager that just wants more SpaceCat. So I'm going to go to tabs.html. And we're going to change the tab title to SpaceCat in Visual Studio. And now since I'm that kind of a developer, I am just going to go and commit my change right away without testing it, because what could go wrong?
We are vagabonds. We travel without seatbelts on. We live that close to death.
So we'll do a commit up to our Visual Studio Team Services repo. Needs more SpaceCat. And let's make sure we don't have anything more than we were expecting so that it all goes well here. Okay, that'll be fine.
Yeah, just commit the.
And we're even just going to commit it right away and just push it on up to the server. It'll be fine. No need to worry locally.
Right.
Okay.
All right. So
it's
with
on
that,
its way up.
let's head on over to Visual Studio Team Services. And go through here. Let's see, we're going to go to our build. This is essentially where the build section is where we've defined all of our build definitions. So every time there is a check-in made, we are now going to execute a set of steps. And do you mind going to edit on that Android build? So
Yes.
we can actually look at
Okay.
Yep, there you go. Thank you. Click it again. Oh, there it is. Just a little bit slow. All right.
Okay.
So here's where we're actually kind of processing the build once it gets up to our Git repository. So the first thing that we're going to do is we're going to do an npm install because, well, we've got a bunch of package.json packages that might be in there. Next, we're going to do a gulp build because this is the gulp build task, which moved all of our files from the app directory down to the www directory. So that's necessary. Then we're going to do our Cordova build. In this case, we're only going to build for Android. You would often want to do separate builds, one for Android, another one for iOS, and another one for Windows. And then, in this particular case, we've just made every check-in to master, again, because we live dangerously. We've made every check into master automatically publish the app. Under kind of a more controlled environment, you would probably want to only publish automatically when developers checked into a very particular branch, like a publish branch. And so if you wouldn't mind, click on the release update to staging. Oh, you got there, all right?
Yeah.
So here you see we've got some of the parameters that we're defining here. And the major one here to pay attention to is that access key. And essentially, every code push application has a kind of secure access key that identifies it and makes it basically says to the end device, to the mobile device, I am an authority. I am allowed to actually push this application down. I am a real, I am the authority for this app. All right. So now, since we've built it, I'm hoping it's actually finished building yet. Maybe.
It's probably still going on right now.
Is it still going? Queued 2 minutes ago. We can actually watch the guy running, waiting for console output from an agent. All right, so looks like it's gonna, oh, here it goes. So it's actually building up here in the cloud, and as soon as that guy is finished building, it's going to launch out to kind of the code push server, and our application will then be able to check for updates. So we see this guy building. Let's go ahead and let's make sure that we've got our device out so that we're ready to check for that update.
So here is our hidden little
Here's
check
our
for updates
hidden
button.
check for updates one. And we'll hit that in a moment. So let's do this. We're kind of getting close to the end of our hour. So we're going to let that continue building, and we'll come back and check for the update in a second. Skip on back over to our slides, and we'll just kind of wrap up for folks while that guy's building.
All right.
Awesome. All right. So kind of at the end of this, just wrapping it up, what you're going to get with Cordova and reinventing the web, Rockstar UX? Oh yeah, Rockstar UX. Faster time to market by virtue of shared code and zero code redundancy. Productive tool chains using TypeScript that allow you kind of better agility when you're navigating your code, refactoring your code, and really learning your code, right, by virtue of IntelliSense. Consistent workflow for all platforms, whether you're deploying to Android, iOS, or Windows. You're able to use the same code base and the same workflow to deploy to all of them. And you deploy when others can't by virtue of code push. Lots of cool stuff that you can get today. You can get Cordova tools with Visual Studio 2015. It's under the Cross-Platform Development tab in Visual Studio Setup. Within Visual Studio Code, you can get the Cordova Tools extension. Visual Studio Team Services provides all of the good mobile DevOps flavor you need. And then Code Push, which today is in beta and continues to be free. With that, we'll take Q&A, and let's check to see if our app has finished yet, and we can do an update.
All right. So we switch back to the VSTS instance and see what's going on here. It looks like it's still right now in the build phase, but I do have, from a different set of changes, I do have one queued up.
You got one
it
queued
won't
up?
show a space cat, unfortunately,
Oh,
but
it's okay. It's
you
all
can
right.
see the
Let's see the
action
UI
here.
for it.
Oh, it's leaving up the presentation for everybody. That's fun. Okay. Now we switch back here. What I've done is I've tapped this check for updates button, and we call the code push API to check to see if there's an update. And then we can put up this prompt if there is one. If I say yes, you would see the app contents get reloaded. In this case, this is a different update that was queued up, so it doesn't have the space cat button. But if it did, you would see that the app will come back up, and that button would be changed. In this case, we were doing some work around the sign up here. So you may have noticed before there was something that said account. We've removed the account link from this UI, and so now it just says login down there. So it was a change to the app's core navigation model that even pushed out dynamically without requiring a round trip through the store.
Awesome. Super cool. All right. So we got a couple minutes for Q&A. You guys have been gracious about asking a couple of questions as we went through it. What's left? What can we answer? What can we talk about? Let's geek out.
How do you get it to the store for the first time?
The question was, how do you get it to the store for the first time? Your first push has got to go through the store. So you always have to deploy to the store once because, you got to get it there, right? Once it's there, anything that only updates HTML, CSS, JavaScript, images, basic configuration, all of that can be managed through code push. And then anytime you update compiled code, which usually means either updating plugins or updating platforms. And Cordova Platforms is actually a technical name for the iOS platform or the Android platform. So if there's been an update to those and you want to get access to, bug fixes, security improvements, that kind of thing, you would have to redeploy there. I will add to this, one of the things that a lot of developers end up asking me is, with code push, you've got the power to update quickly, but that also means that you have the power to break people quickly. And so how do you guard and kind of protect yourself from making a stupid mistake? Because I don't know about you, but I make stupid mistakes all the time. Really, the key there, one of the features that we implemented with code push is the ability to deploy to only a small or any percentage, an arbitrary percentage of users. And so a lot of our developers will end up deploying to maybe 3% of their developers or their customers randomly, and then they'll watch that deployment for maybe 5 days or a week, see if there are any problems with it, and then push it out more broadly to their larger developer base. So that's one strategy that you can employ. Another one is that if you realize that you've done something stupid, then you can retract an update, and it will do two things. First, it will prevent anyone else from getting that update. And second, it'll automatically take anyone who has adopted the update and prompt them to, it won't tell them that they're rolling back, but it will essentially roll them back to the previous update. So we're essentially managing a history of all your updates over time, which is super helpful. What else?
If you have schema changes like that, if you progress forward, you may break that rollback. Is there anything that you can do to, I guess, provide that mechanism for maybe converting back if that's possible?
Okay, I'm going to paraphrase what I think I heard so I get the question right. So if you've moved forward, and by moving forward, you add some major schema changes. Here, I think you're thinking like data model changes, right? And you decide that you want to roll back. The rollback may not be compatible with the new data model. So if your data model is expressed in JavaScript, then you should be fine. But if it was changes to your web services that you're using, then you're going to have to change your web services on the server side as well. So there's nothing that necessarily coordinates your web resources, your server resources, service resources with your client-side ones. That's something that you will have to coordinate yourself. Great. But good question. That's a really good one.
How secure is the code push itself? Like how do you make sure you are identifying the code push that you're pushing the code, nobody else pushes your code on it?
Yeah. So the question was, how do we lock down the code push service to make sure that there's not like a man-in-the-middle attack or something like that, so that someone doesn't falsify the identity of the code push service, therefore, leaving people to download a malicious package. Is that right? Yeah. So there's a couple of ways that we do that. Really the big one is there is that key, right? Every app has got a long key. I think it's like a 64-character hash kind of thing, right? When you code, in fact, if you bring up config.xml in code, you can see it. In config.xml, that key sort of specifying the identity of the code push service is in there. And so there's a key match that happens there. And that key match gets compiled so that you can't actually see the key in your JavaScript, and it gets hashed every time that goes up to the code push service. So there's a handshake that verifies identity between the code push server and each of your mobile clients. Does that make sense? Yeah? Awesome. I think there was another one that was maybe in this general region. Did I hear it? No? Oh. Does it support in-app purchases? Yeah. Yes, you can, it does support in-app purchases. That would be through, I believe it's actually called in-app purchases plugin. So you can totally take advantage of any of the store in-app purchase features that are available. There is nothing that, or at least I have not explored or found anything that supports any kind of in-app purchases that are outside of the normal store ones, except for normal retail stuff, right? Like, you know, e-commerce. There are plenty of e-commerce Cordova applications out there that make use of any one of the many myriad e-commerce retailers. But I think you were asking about the store in-app purchases. Yeah. Awesome. All right. Well, we're kind of here at the end of it. I strongly encourage you guys. I did not realize that there was a table yesterday with my name, Ryan J. Salva, on it for the Birds of a Feather lunch. So I sat at a General Xamarin Cordova development table. So if you missed me, super sorry about that, but let's talk afterwards. I would love to geek out with you guys. Jordan would too. With that, thank you so much. Enjoy the rest of the conference, and don't forget to join us this afternoon at 4 o'clock. There's going to be an awesome panel, Making Sense of Mobile, with myself, James Montemagno, and Josh Weber from the Mobile DevOps team. So we'd love to talk to you more about mobile at that time.
Yeah, that'll be 3:45 actually.
3:45. Awesome.
And then after your lunch, which I guess right now you guys get to go over to the Mixer Visitor Center company store area. You guys come back. I saw that over in St. Helens there's a session by Ted Neward on the Busy Developer's Guide to ECMAScript 6. That will help deep dive into some of the stuff we touched on here, so that might be good to round out your day, and then come back and see us at 3:45 in
Cascade Room. Same
this room right here. Great.
Awesome.
Thanks, everyone.
Have a good one, guys. Thank you so much.